All right, so we are about to go over the circular interpolation here for our um, bolt circle and our holes and how we can kind of use an end mill to go back in and do a counter bore. So I've got all of my hole positions and my coordinates already calculated out over here in my uh, tab file here. And I've got my beginning line codes already written. Now remember, for our machines, uh, this prep code, kind of the layout of the program, is going to be the same on all these. So I'm assigning it, on this one, I'm assigning it program number 1610. So I've got my preparatory functions here on line N10 and line N20, my work shift here on line N30, and then of course I'm using tool number 3. So I got my height offsets, and I'm specifying what the cutting tool is. Line N50 turns my spindle on. Now, the first move that I'm going to make is going to be a rapid move to the start of the center of the hole that I'm going. And for this operation, I'm going to use hole number 6. So on my rapid code there, I'm going to come down and I'm looking here. Okay, the center of hole number 6 is at minus 2.814 in the X. So I'll go ahead and I'll put this minus 2.814. In the Y, we're at 1.625. So I'll go ahead and make that 1.625. All right. My next line, then, I'm still in rapid mode. I'm going to go down to 100 thousandths above the part. Then I'm going to switch over to a GO1 and go into the part. Now remember, according to our print, this counter bore is 3/4 of an inch deep. So I'm changing now. I've got my feed rate specified, and I'm going inside the hole at 3/4 of an inch deep. Now, my next line of code here will be to go in 90. I'm turning cutter comp on. So, and I got to give it an X and Y position. So we'll go here too. We've already calculated this out. That position is position 21 here. So we're going to go, and I will put X of minus 2.219. Your Y here will be 1.625. And of course, that diameter offset, our cutter compensation there for our diameter is held in location H13 on our machine. Remember, in other machines, this would probably be a D value here instead of an H. So just some of the differences between our machines. Okay. Now, my next line of code, I'm going to go to a G3. So this is a arc move. So, and that's going to go to position P22. So I'll put in my X value here. So X minus 2.814, Y of 2.20. Now, when we do a G3, we have several different ways that we can do this. We can either do it the quickest and easiest, just using a radial value or an R. And we've already discussed some of the problems with the R value, as we can't do a full circle. We can only do arc lengths up to 180 degrees with that. And that sometimes the machine does not really give us a true arc or a true radius on there just because of the machine control. So you can get some problems. The better way to do it is, of course, usually with the I's and J's, but a lot of times people get confused with the I's and J's. So we're going to do this a couple of different ways just so you can kind of see what's going on here. So I'm going to first put we're going to do it with the R value here first, and we already determined that our radius here is going to be 595 thousandths. So it's going to move to that position. So, all right. Now, our next value here will be in. So we'll go ahead and put in 110. We're still in G3, but now we're going to go to we're at position 22. We're going to go to position 23. So I'm going to go X. So we'll type in x minus 3.409 y of 1.625. So r still in the GO3, 0.595. Next one will be N120. So now we're going to position 24. So we'll go x minus 2.814 y of 1.030. Again, r value 0.595. N 130. And now we're going back to position 21. So x of minus 2.219. Got an extra 2 in there, so be careful. Double check your work. So, of course, when we go through and plot this out, we'd see issues. So, and then y here will be back to 1.625. Again, our R value is 0.595. So that brings us all the way around the circle. Now we can go back now in 140. We're going to turn off that cutter compensation. So, but this is, instead of an arc move, we're going to be a G01. So we got to go G01 here and G40 to cancel this out. So, and now we're going to go back to that center point. So we're going to go back now to x minus 2.814 y of 1.625. So now notice I had that G40 line down here, so kind of already there. So I've just written it. So we'll delete this out, kind of back this up. At this point, we're done with the counter bore in that hole. So the next line of code, of course, will be to get the cutting tool out of the hole. So we're going to go back. I'm still keeping this as a G01, and I'm feeding to 0.1, so 100 thousandths above the part. Then I'm going to go into a rapid mode of 1 inch above the part. So then I will turn my spindle off and kind of either go to the next point here or go to some type of a safe positioning move. Then that shuts my program off. Now, some people, and sometimes you may also decide, hey, we're okay to just put a rapid move here and go rapid move out of the part to Z.12. So different people do it different things. Now I'm going to expand this out for a second so we can kind of see what's going on. So let me plot this out. So here we go. So everything looks pretty good. I'm going to step this through. So as we step it through, so there is my point, comes there, go, our cutter compensation turns on, there's a radial move, radial move, radial move, and radial move. So we've gotten that in there. Now, so I've gotten those 4 points. I don't necessarily need those 4 points. I could probably just do this. If I think about it, I could do this at 180 degrees, so I would just kind of need 1 point here and then to go over to that point as well. So kind of depends on what you want to do. So in that case, I would just change my point position. So now, so as we go through this, so this is with the R value and it works. So now we're going to write this with the J value, but I'm going to stop this video and we'll come back and redo it with the I's and J's.